Good afternoon, ladies and gentlemen, and welcome. I'm Marty Eudicious from the QT Company, and I'm here to be your host today and introduce our next speaker. This is Adrien Leravat with Witekio, formerly Adenio Embedded, and he'll be talking about a real-world use case of QT with IoT. Adrien, go ahead.
Thank you. Hello, everyone. So thank you for attending here. Thank you for being present at the QtWS Summit too. So let's go ahead with predictive maintenance, a bit of what, a bit of how, presenting you what we've done about that, and then if you have questions, we can go away. Okay, so first thing, predictive maintenance, and what is that? So couple things. There's three different cases. The first one is three different types of maintenance: the corrective maintenance, the predictive maintenance, and the middle one, the preventive one. So if we take a simple analogy, the corrective maintenance, if for example, imagine you have your car, but in that car you have no fuel gauge, right? So you have no way to tell how much fuel you have in your fuel tank. So that's the only way to know that you don't have any more fuel in your tank is actually to run out of fuel and be stopped in the middle of the highway, say, okay, now I need to get back to station, put some fuel in that, and that's a problem because the failure already happened. So you're in the corrective maintenance mode. The failure already happened and you need to do something about it. The second case is the preventive maintenance. Now you say, okay, I know my car will run out of fuel at some point, so let's say I put some fuel in the tank every week, and I should be good about it. Except, you know what it means, you drive a little faster, you don't have the same consumption every time, and so you can run out of fuel earlier or later, and it's not an optimal way to fill out your tank. So easier planning, because you can plan the intervention, but not optimal. And the last way is the predictive maintenance. So now we can simply put a sensor in your fuel tank, and you have the information right on your screen, and you can say, okay, now let's go put some fuel in that, and you have no more problem. So in that case, you are the intelligence, right? We'll talk about machine learning a bit later. You have the information of the sensor, and that's up to you to do the action. So is it right for you? There's different cases. If the failures are acceptable, if it's okay to have the customer call back your assistants and say, I already had a problem, or bring back your product, then corrective maintenance is fine. I mean, it's the cheaper option, no doubt about that. If there is also no budget or it's hard to detect a failure, you can go for preventive maintenance. So you simply say, every other week, for instance, let's check the machine, let's go change some consumable or anything. And the two other options that interest us more are the condition-based predictive maintenance and the model-based predictive maintenance. Now, the condition-based is okay only if it's easy for you to detect a failure. Like if you have, we'll see just after, if you have that kind of temperature, then it's very easy. If you know that you have a specific threshold, and above that you have a problem. For other cases, we'll go for model-based predictive maintenance. So a bit of details, and after we dig into the implementation and how we manage it, or how we recommend to do it. So condition-based, simple case, and it's just a trigger. So basically, we'll send information to the cloud. We'll see, you detect the current, for example, of the motor. You need sensors, you need information, right? And from this information, you can deduce you have a problem in your machine. So it's very easy to implement, but of course, it's quite limited. You cannot test manually all these different conditions. And then there's the other case, which is the model-based condition monitoring, which fits a lot more complex case. Actually, that's what also NASA use for its launcher, so a bit more complex. And the idea is that you will produce a data set, so you need information for what's the sensor, the value of my sensor, and what state it corresponds to. Is there a problem or not? And from that, you can build a model that will learn on this information and be able to tell you, okay, I have this input, now something will probably be wrong soon, and you need to do something about it. So it can cover a more complex case, and it's a bit more work to implement and maintain. And the last thing about the theory is how to plan it, what to do about that. So there is two steps. There is the prototyping and hardware phase. So the first thing is to know the signs that will occur before you have a problem. So it can be anything, but for example, the coffee machine that we'll take, for example, the thing that makes the espresso actually is a motor that compresses the coffee, etc. And if you have a problem on the motor, you will have vibration. And you can detect this change of vibration level and say, okay, the motor will probably have a problem soon. And once you have this information, you need to integrate the right sensors, of course, because there is no predictive maintenance without knowing the data behind the problem. And on the software side, you have to simply monitor the sensor, notify the change, usually to the cloud, create a model either manually or automatically, and train that model on data, and then finally integrate that model and the prediction inside your whole system. All right, let's see a bit more in detail how to do that. So there's two big ways. The first one is with big commercial solution. This is not the way that we will explore today, but a lot of big solution, turnkey exist already, more or less easy to integrate, and usually best fit for big scale operation, complex solutions. And of course, less technical knowledge known. The one that interests us more is the custom solutions. It means that, well, you have different technologies. You have a lot of open technologies. You can put all the pieces together and create your own system. That's actually what we do with Qt, right? We have an open source technology and we build our own stuff, and that's what's funny to do. And so it will be tailored for your context and tools, and it will require, of course, a bit more technical skills. But that's fine. So let's have a look at the basic condition base. We have our coffee machine like the one we have at our booth, and we can just send some simple information. For example, the number of cups served or the quantity of coffee grounded, and we can send all that to the cloud. We'll explain a bit later why the cloud especially. And then simply in the cloud we'll do, well, if we have made, for example, 1,000 cups, probably we should check the motor. So at that point we will signal a technician that he needs to be present on site and verify the machine, check the machine to make sure everything is okay. And of course, that allows for better quality, increased lifetime and uptime of the machine, because you will fix the problem normally before they appear. That's not the optimal way, but it works. And the question is, in that case, why should we use the cloud at all? Why should we have this internet connectivity and everything? And the key thing is that when you build such a system, you need to make it able to evolve, to be upgradable when you have new information, when your system changes, etc., without modifying all the software you have on your product. And that's why it's a lot easier to just update the algorithm you have in the cloud instead of upgrading every machine you have in the field. And the second reason is for the connectivity to other services. Usually when you have this information of there will be a problem on your machine, you want to notify someone. You want to say, hey, please come to the machine. So you want to send an email or to connect it to, for example, a ticket service or anything. So for that, having that logic in the cloud is essential. Okay, so small architecture around that. Small diagram. So we have on the right the local stuff, we'd say. On the left, you have the cloud business. And what you can see that if we start from the right bottom, you have your local device and you send all your information to the cloud. We try to use HTTPS, of course. We are at a time where we cannot afford to just not use secured connection. It's just not possible anymore. So in that case, that's HTTPS certificate and everything. And we have a web API brick. So that web API brick is actually where we'll put the logic, even if really limited. So in our use case, we use the Elastic Stack. So if you don't know that, that's just a stack that is used to parse the data, to store it in a specific database kind, and being able to detect things and notify, etc. There is other alternatives. You can make that, of course, in PHP, Node.js, Java, or whatever you want that you can put on the cloud. And we connect that web API either to a supervision website, a ticket system or of your own or another one, or send simply an email to your customers or to your technicians. And the last brick is, of course, the supervision website. So in our case, that was a Jira website, which meant that automatically, when you have your account, the service would send you a notification, create a new ticket, and say this machine has a problem and needs to be fixed, which is quite neat. So this is the architecture. Now, if we dig a little in the code, so I'm sorry, usually I love to show some very deep code technical stuff. This is a bit more high level. So I put it just to not be too, to put some code actually in the presentation. But so you have different steps on the device. The first one is to monitor your sensors, of course, that you have put. So if you have the chance to have the right driver, you can just open a file on the, here we are on the Linux system. You open a file with the right path, you read the value. So this is really very simple, cute code. Then you serialize data. So we use simply a QNetwork Access Manager to send data to the cloud. I even skipped the HTTPS part because it's a bit more code, a bit too much code to be included here. We put the data in the JSON and we send the JSON directly to the cloud by calling our API. So this is just a standard URL that you have, and behind that you have your Node.js or your Elasticsearch server, and it will just hit the data, store it, and use it as you want. I also like to use the not so new but still present feature, the category debug log category, because it's fine. And when you use so that's the QcDebug, you can use that to just process the logs differently. So for example, for all the sensor-related information, you can put that in a specific log or store it in a specific place, or just directly send it to the cloud. Just a detail. So that's the device part, and then we have the web server part. So there is three big pieces. The first one is the parsing. So in that case, we'd use Logstash. So Logstash is a brick that is part of Elasticsearch big framework. You can also do that manually, of course. That's simply JSON, so you can parse it manually. The second is storing, and storing is really an important one because you don't want simply to send data to the cloud, do your test, send an email, and that's it. The important thing when you build a predictive maintenance system is that you need to have enough data to improve your algorithm, to be able to process it differently and output the right result. And for that, you need a lot of data. So that's why every sensor information you have, you need to store it. And you also need, at some point, to associate a state. Like, for example, I have this data, and at that point, there was a problem on the motor. If you don't have this information, it's just not possible to create good quality or just to make the algorithm evolve to provide a good output. So in that case, Elasticsearch can be MariaDB or anything really for the storage. Elasticsearch is convenient because you can store just any kind of format, any kind of data, like NoSQL-like. And finally, you have the alert. So in our case, that was Watcher, which is also part of Elasticsearch, not to make any advertisement. And this is the kind of way it is written. So it's not QML, actually, but it's a JSON-like format. And you say, so just above, not enough space to write it, but you write your condition, and you say when the condition is reached, the action is send an email to that person, in that case, an operator. And you simply, for example, add the name of the machine, and that's it. We also added some attachment with some details about the machine. So that's the base for it. And the question is, is that just it? Just a bunch of if somewhere in your code in the cloud and you have done predictive maintenance? Well, it depends, but that's the basic version of it, and it can still be called predictive maintenance. But we can also go beyond that, of course, and use AI. That's the interesting part, which is called model-based predictive maintenance. Okay. And the idea is that we will simply bring machine learning into the mix with this nice little brain on the side. We'll use this intelligence to actually drive all the logic. And instead of doing simply a if, we'll learn on the set of data. And we'll use the learn to make a prediction to say there will be or will not be a problem on my machine. So we actually output the same data from the machine, just adding this brick. In that case, like for your car, the maintenance costs are, of course, optimized because you don't need to go there every time. You just need to go when there is a very high chance that you will have or you already have a problem on your machine. And it's a solution that is self-improving because like we've seen before, the goal is to send a lot of data to the cloud, to store it, and after to improve your model. So it's not just a one-day solution and it just doesn't change. It's something that is meant to evolve to reach the right level of quality. And of course, how do you do that? So first step is choosing your machine learning toolbox, your tools. There's we could call it the good old ways using dedicated tools. So you can use MATLAB, you can use R, you can directly call script from R, create your machine learning, etc., and use it. That requires some knowledge, but that's one way. The other way is to include a dedicated library. Again, you need to write some specific code, but it's doable, no problem. So that's just a short list of it. For example, there is Shark for C++ that you can add. And the last one is to use machine learning API. That is really a neat solution. And the idea is actually you just count on someone else, some other service to provide you all the machine learning intelligence and everything. And you just connect to it from the cloud. And that's what we use here. So Google made its own thing, Amazon, Microsoft, etc. And Seldon is an open source actually solution that you can use, so you don't have to pay for it, which is great. Not the only one, but it's a good one. And here is our architecture, just slightly different. Now you have your message broker and machine learning API, and the time is very short, so I will go very quick. The message broker, the goal of it is to simply have information when you have disconnection about your machine, and to be able also to use queues. It means that your machine wants to send data, but even if it's not connected, it will be able to send all the data missing when it will reconnect. That's one of the good points of the message broker that we use, which is AMQP. RabbitMQ, which is the related server on the cloud. And for the machine learning, in that case, we use Microsoft Machine Learning. So sorry, this one is not open source, actually. And in fourth step, very quickly, up, you have to choose your metric. In our case, we choose the failure probability. You have to build your data set. For this demo, that's a very short one, very simple one, which is actually was made with Excel. So it's not the typical way you made your data set, but that was the good one just for demonstration. Generate your model, learn with it, and finally integrate the API into your complete system. Okay, so it looks like that. I don't know if you can actually see the numbers. So on the left, you have, for example, simulation, if we can say, of a vibration intensity. And on the right, you just have a 1, 0 to say, is there a failure or not? And what we did, which is a simple example, but that gives you an idea, is to use a linear regression model. So the goal is to fit a line on this data and to be able to output a probability depending on the vibration you have. So you have all this model that is actually made directly with the Microsoft tool. So you take your data, you split the data, you make the machine, the model learn, and at the end you have a result that tells you what's the quality of the model, of the value that you have learned and the model that you created. So for Microsoft has this thing, well, it's very easy to create the line, etc., and configure. And in the end, you have simply that. So it's actually just a couple clicks and it does work. From your learned model, you just output it to production model, and you make it a web API. So you have a web API that uses the model that learned on your data, and you can just use that API to say, here is my data, what's your prediction? So it's just a call from the cloud, and it gives you what you have at the bottom of the screen, which is not easy to read, but you have the 0.5 and 1.5 something, which is actually the prediction of the failure. So 2 cases with the prediction output. And from this prediction, it's very easy to do what you want to say. For example, if it's over 1.5, then let's have a maintenance. OK, final thing. Timer running very short. So if you want to go a bit further, you can use this kind of representation, which is Kibana, just to have visual overview and help identify trend and anomalies. And all these good points, lifespan, better uptime, optimized maintenance, etc. And in addition, when you have that, it lets you know your users better, and it lets you also improve your security because you can detect some fraudulent and unusual behavior. That's it. Plan to integrate your sensor, define what should be your machine learning output, so a probability or remaining useful machine life. Make sure you can update the prediction because it's mandatory, and store your data, and then enjoy presenting the result. And yeah, put a sensor on that fuel tank because that's really better with a sensor. That's it. Thank you. We are Witekio, but let's keep that. We can talk at our booth and enjoy QtWS Summit like me.